Alright, and welcome back. In this video, I'm just going to cover a couple more examples of graphing sine with amplitude changes, period changes, midline changes, okay? Now, there is something called a phase shift that I'll get to in the next video, just as one last little change, okay? But for some of us, this will be kind of the last thing that we need to see, okay? So, take a look at this function right here. We got y equals negative 2 sine of 1/6 x minus 1. Okay, so if you want, go ahead and pause the video and try to find out this information. If you want to sketch a graph, go ahead and feel free to. I'm going to jump right into doing it, though, so if you want to try it on your own, pause it right now. Okay, so amplitude, remember that is the absolute value of A, which in this case is negative 2, so the amplitude of this case is 2. Just remember what that negative means. This negative right here means it's reflected over the x-axis, okay? All that means is that instead of going up, instead of going to the maximum, immediately, we go to the min. Remember, that's really all that means. The pattern is going to stay relatively the same. Instead of rising, we fall. Negative, just falling instead of rising right away. Okay, and then from there, our midline, well, we have minus 1 outside, which means that we're moving down 1. So our midline is y equals negative 1. So I can actually get a graph going somewhat with this information. Let me see if I can make that a little bit straighter. Whatever. So our midline is at negative 1. And since the amplitude is 2, I'm going to have to go up 1, 2. So I'm going to have to go up to 1. I'm going to have to go down to negative 3. So remember, amplitude is how far above and below the midline you need to go to hit the max and min. So up to and down to. And remember, you don't have to actually plot the midline with a dashed line, but I like to just for organizational purposes. Okay, and the rest we figure out with the period, and that helps us figure out the scale for x. Okay, so the period is always 2 pi over the absolute value of b, which is 1/6. Okay. Now, what this is going to end up becoming, dividing by 1/6 is the same as multiplying by 6, so that's going to give us 12 pi. Remember, that's the same as saying 2 pi times 6. Okay, dividing by 1/6 is the same as multiplying by 6. Okay, so that means it's going to take a total length of 12 pi horizontally to finish one full cycle. And remember, to find our scale, we take the period and divide it by 4. We take the period and divide it by 4. So that means we're going to be going by 3 pi. So I add 3 pi to 0 to get 3 pi. I add another 3 pi to get 6 pi. I add another 3 pi to get 9 pi. And I add another 3 pi to get 12 pi. Okay? And now we can go ahead and graph. Remember, sine always starts at the midline. The pattern always starts at the midline, and now instead of going up to our maximum, because it's negative reflected, we're going down to our minimum, so down 2 to the minimum, then up 2 to the maximum, or excuse me, up 2 to the midline, up 2 to the midline, then up 2 to the maximum, then down 2 to the midline. So this right here would end up being one full cycle. Okay, that would be one full cycle. You can continue going if you really wanted to. I could keep going and make this 15 pi and this negative 3 pi. I can even keep going, make this 18 pi if I really wanted to, okay? But one full cycle is enough for me, okay? Okay, so let's try one more example. So I'm going to scroll down a little bit. Let's try one more example. I'm going to make this one just look a little bit different function-wise, but you tackle it the exact same. So let's say something like y equals 2 times sine of pi x plus 3. Okay? If you want to pause right now and find all that information, go feel free to. Okay? But I'm going to jump right in. So the amplitude. Well, the amplitude would end up being 2, right? So Amplitude is 2 because the absolute value of A is 2. And the midline, well, we got shifted up 3, so it's y equals 3. So I'm going to go ahead and start sketching that out. Well, the midline's up at 3, and I got to go down 2 in each direction. Okay, so 1, 2, 3. There's my midline. I need to go down 2 to hit my minimum, and up 2 to hit my maximum. Okay, so I got to go up to 5 and down to 1. Okay, and now I got to figure out what my x scale is going to be. Okay, so I need to figure out what the period is. Well, the period is 2 pi over the absolute value of b, and b in this case is actually pi, which reduces 2 pi over pi. Well, the pi's cancel, which get us just 2. That is okay. That can happen. Pi is just a number. Okay, that's all pi is. Pi is a number just like 2 and the square root of 3 and another one called e, if you know that one. Okay, it's just a number. Okay, so don't tweak out. The pi's canceled, that's fine. So the period is 2, which means the x scale, we always divide by 4, which means the scale is going to be 1/2. So we go 1/2, add another 1/2 to get 1, add another 1/2 to get 1.5. I'll write it as 3/2, and another 1/2 to get 2. And now I can go ahead and start the pattern. I'm going to go ahead, plot that midline. Sine starts at the midline. And now this hasn't been reflected, so it's positive. We go straight up to its maximum, up 2 to the maximum. Amplitude is 2, up 2, then down 2 to its midline, down 2 to its minimum, and up 2 to its midline. And that would be our graph. Okay, so that's graphing sine with a bunch of changes. Okay, if you want to go ahead and check out the next one, I'll talk a little bit about what's called a phase shift as just one extra element. Okay, if not, if you're good with this, I'll go ahead and start talking about graphing cosine. Okay, so stay tuned and make sure you're practicing.